आज जो हम प्रॉब्लम सॉल्व करेंगे उसका नाम है फाइंड मीडियन फ्रॉम डेटा स्ट्रीम. So we are going to solve this problem. Like I will tell you briefly what is the problem. You will be given input as this. Like first time you will get a median finder, then add num again, then find median, add num. So basically we have to write an algorithm so that every time when we called as add num, we will add that integer into the storage where that we will create, and every time we have been called a function called find median, we have to return the median from all the elements that we have stored till now through add num function. Okay, and how we can get the median? Suppose if the array length is odd, then we have a median length as only the length of the array divided by 2. That's the middle element. And if the array is of even length, okay, then we have, for finding the median, we have to do two things. We have to create a sum of n by 2 element, like n by 2 its index element, and plus n by 2 its minus 1 element, and then divide it by 2. Here you can see there are even even size of this array. For that we take n by 2, n by 2, 2 by 1 is 1, okay, and divided by 2, that's a 2.5. So we have to write the algorithm of finding median and efficiently adding the numerator. And median finder is a code to create that object, or called a constructor. Okay, so let's start with this problem. What we have to do? We have to do three things. First, adding number. Write solution or function to add the number. The second one is find median for all the elements till now. Find the median. Okay. And how will you find a median? If n is odd, median is equal to array dot size divided by 2. Even केस में टू थिंग्स होगा हमारे पास. मीडियन इक्वल टू array of, suppose here you can take one thing, n equal to array dot size. Okay, now median equal to array of n equal to plus array of n by 2 minus 1. Okay, divided by 2. That's median if even case. So you have to write it. First of all, choose the storage. Okay, how will you choose the storage? Simply get the median. I like the top. I like this thing, this thing, and this thing. How will you get that? Okay, suppose if you choose a vector int, okay, vector int elements. Okay, whenever is called void add none with integer k, we'll just do elements dot push back k. Okay, and suppose we have to find, no sorry, we have to okay, this is called, how will we do? First of all, for getting the median, we have to sort it. Okay, so we'll sort it, array dot begin comma array dot end. We sorted it, then if int n equal to array dot size, like we will find the size and then check if n equal to, sorry, that is even. If it is even, then return what we have said, like array of n by 2 plus array of n by 2 minus 1 divided by 2 times 0. Okay, here the 0 is because we are returning a double, that will make it double. We don't have to create anything else. Okay, that's in the case of else. It is the odd one, return array of n by 2. Here you have to write a double, like okay. So this is a find median function. That is all we need. Okay, that's we all need. But that will give us a TLE. That's a time complexity. Let me tell you. How will we get a time complexity? Here, like every time we are sorting, sorting makes it n log n time complexity. Okay, so it is taking too much time to sort it. Every time we are sorting, every time we are sorting. Okay, let's write this code. Suppose we are taking element vector and elements. Okay, here we don't have to do anything. Here elements dot push that. Okay, we have to do one thing. Sort elements given. Okay, and equal to elements dot size. We have to find the size. Then if n divided by 2 equal to 0, that means it's a even number, like even size. Then we have to return elements n, 2 plus elements n by 2 minus 1 divided by 2.0. Okay, else return double elements n by 2. Alright, that's it works. Let's check out. Okay, my bad. Elements. So is there anything here? Let's put it like this. I think it works. Let's check it out. Yeah, it works. Let's figure time complexity. It will give really, yeah. Let me tell you the time complexity. It will be too much time complexity and log n of every time. Thinking of time complexity, it is not giving me time complexity. Okay, no issue. Okay, we have to optimize this. That's our bottleneck. Let me tell you what's our bottleneck. This thing. Sorting, like preparing everything, like preparing every time we want to find a medium. So what we can do, we have a better approach that's called better approach. What we will do, think like how can I get it sorted every time without without too much time, and also need index to find the middle element. Okay, think like that. How will you think it? Can you guess anything? For sorted, we can take like what we call map sorted. We have element line element and index. How will it help? Like, how will I getting median? Like, how can I get the median? Think something. How can I get the median that is called ny2 or ny2 minus 1? How I can get these things from map? I can't get it. Can you guess anything? Can we guess anything? How can I get ny2 and ny2 minus 1? I don't get it. If any time we have left and right, like can anytime suppose we have a storage array equal to if we can get something called 1, 2, 4, 6 and 8, then we can, how will now that's the problem. how, how will I get original size? Like, yeah, I can get it. My condition will be for odd left dot size will be greater than right dot size. Okay, and even equal to left dot size equal to right dot size. Okay, so yeah, I can get that. For odd I can easily get as return left L size -1, and for even I can return left L size -1 plus right का क्या 0 divided by 2.0. Yeah, I can get it. Also, now tell me one thing. As we will split it, like we have to keep sorted so that it is last element, like its first element will be here. It will sorted ascending and sorted descending. Why don't we use max heap and here min heap? Yeah, we can easily get there. So now our problem will be like this. We have to create priority queue max heap for left side. I can't I can call it left, okay, and priority queue int int greater int right. That's a min heap. If you don't know this, that's for making in descending order. Like by default heap is a maximum. Here it is called as min heap. Yeah, I think that's called it. Let me check it. Declare min heap and max heap. Yeah, max heap is by default this. Min heap is like this. Okay. That's good. So now how will you add things? Like, how will you add num? Add okay. how will we add them? Before that, we are just doing add num is element dot pushback. Okay. Now we have to do like this. We have to push in anyone. That suppose we are adding only left dot push k. Okay, left dot push k. Now suppose we have added this. Okay, then we are getting left one as 1, 2, 3, only getting left, nothing in right, nothing is getting right, right is empty. So we will write another function called void balance. Okay. Balance will be like our scenario is our left can be bigger, but by only one greater than right. Like here you can see it. Your left जो है, ये जो left है, this left is 3 lengths, and right is of 2 lengths. It is every time kept at this because we want for odd cases we want to return the last one, like from the left, not from the right. You can vice versa it also, but this is my approach, like I get here like this. So balancing, what we can do for balancing, if how we can get here, how can I get there to get anything, like suppose we are putting in left, okay, second time we are putting in a right, like if we write condition if right dot top, okay, right dot top, here you can write if left dot size is greater than right dot size plus 1, okay, then we can we can do right dot push left dot top, okay, top element, and left dot pop. Like anytime we get in left two elements, like suppose here we can get 2 in 1 and 2, but here right is empty, right is empty also. Here it is 0. 0 plus 1 equal to 1. But here it is 2. Then we have to put here. Like here the size is 2, but here, let me tell you. Here the size is equal to 0. Here the size is equal to 2. That's that difference is greater than 1. So what we will do, uh, remove 1 from 2 from here and put here. Okay, that's called balancing. Okay, else right dot size. Okay, right का size is greater than, तो हमें left dot push right dot top and right dot top because of balancing. But here also we have to do one thing. जो हमने एलिमेंट्स पुश करने का लिखा है ना, इसको थोड़ा वो करना पड़ेगा. डायरेक्टली लेफ्ट में नहीं डाल सकते. यहाँ पर लिखना पड़ेगा if left t या और left is principal नहीं. left dot top put it down. Left dot top element is less than equal to k left dot push k else right dot push k. I guess this works. Let's code it down. No. अब now वो तो ढूंढ के देना है ना. मीडियम का फंक्शन लिखना है. का फंक्शन लिखने के लिए क्या कर सकते हैं? यहाँ पे एक लकीर लिख दो. यहाँ पे लिख देगा डबल फाइन ओके. इसको ब्लू लाइन से लिखना है. ठीक है, तो यहाँ पे क्या करेंगे, कंडीशन लूँगा इफ एक काम एक बार मैं निकाल लेता हूँ. if L size is greater than R dot size, return left dot top, else return right dot top. No, 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 गलती कर दी, गलती कर दी, गलती कर दी। यहाँ पे एक चीज़ लगाना है मुझे, एल्स में क्या करना है, बनाने के लिए जल्दी कर, जल्दी 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 इसमें करना है, हमें निकालना है लेफ्ट डॉट टॉप प्लस राइट डॉट टॉप का सम डिवाइडेड बाय 2.0। ओके, ऐसे निकालते हैं। तो हमारे 3 फंक्शन हो गए, इसको दिखाता हूँ। वैल्यू ऐड करने का, अगर लेफ्ट जो है एम्प्टी है या फिर लेफ्ट का टॉप जो है नए एलिमेंट से छोटा है या इक्वल टू है, लेफ्ट में पुश कर दो, तो फिर राइट में पुश कर दो, ठीक है। उसके तुरंत बाद क्या करो, बैलेंस कर दो, बैलेंस का कोड लिखा ही मैंने। चलो इन दोनों ऑपरेशन के बाद मैं बैलेंस कर देता हूँ। बैलेंस बैलेंस कॉल करूँगा अपना बैलेंस कर देगा, बैलेंस को कॉल कर देगा, बैलेंस कर देगा। अगर लेफ्ट साइड में बढ़ा हुआ राइट से तो उसमें लेफ्ट में उठा के राइट में डाल देगा, वैसे राइट का तो राइट से उठा के लेफ्ट में डाल देगा। ये मीडियन निकालने का है। चलो इसका कोड करते हैं, टाइम हो गया। प्रायोरिटी क्यू इंट को लेफ्ट डालूंगा, मैक्सी पी आर आई ओ आई प्रायोरिटी क्यू इंट vector of this is the syntax of creating a min heap. Okay, min heap. Now let's go, क्या करेंगे, हम यहाँ पे करेंगे if left empty या left of top is greater is less than equal to k, so k नहीं यहाँ पे नन है। इसमें क्या करना है, left dot push none, else right dot push none, बैलेंस। अभी बैलेंस का फंक्शन लिखूंगा मैं, let's write here void balance, बैलेंस में क्या होगा, अभी लगाता हूँ, बैलेंस में ही होगा if left dot top sorry left dot size is greater than right dot size plus 1, तो क्या करो, राइट डॉट पुश लेफ्ट डॉट टॉप का एलिमेंट निकाल के इसमें पुश कर दो, लेफ्ट से ऑफ कर दो, ओके, इस फिर से राइट return left dot size. Okay. To left dot push, right dot top, right dot pop. Okay, this is good. बैलेंस भी कर दिया हमने. मीडियन निकालना है. मीडियन निकालने के लिए हम क्या करेंगे, इसको हटाओ. else size equal to left dot size and r size equal to r right dot size. If L size is greater than R size, that is the odd one case. It is a odd, not off, odd. Okay, and done. Double left dot top. Okay, else this is even. इसमें क्या करना? Return left dot top plus right dot top divided by 2.0. Okay. Long answer. यहाँ पे गलत क्या होगा? लेफ्ट का साइड जो है तो उससे बड़ा है, तो राइट में पुश कर दिया, ड्रॉप कर दिया. और राइट का साइड जो है लेफ्ट से बड़ा है. राइट का साइड लेफ्ट से बड़ा तो भी हो नहीं सकता. तो मैंने कोड तो सही लिखा है. एक तो कहीं पे गलती है. कहाँ पे गलती है? बैलेंस मत कर. साइज का चेक नहीं करना है हमें. अंदर के एलिमेंट का साइज का चेक जो है तीन क्यों आ रहा है? ओके ओके ओके, तीन आ रहा है. अब मेरे को 1 2 3 यहाँ क्या बनना है? यहाँ पे बनना होगा 1 2 3 बनना है ना. 1 2 और 3 बनना होना चाहिए. ये बनना चाहिए. इसका क्या बनना है यहाँ पे? नहीं कर सकता यार. प्रिंट कैसे करेंगे? प्रिंट कैसे करेंगे? हाउ टू प्रिंट heap elements? Is it possible? I guess it is possible. Yes, it is possible. It is possible. from 11th दोबारा कर देते हैं. तो यहाँ पे प्रिंट ही नहीं कर सकते. अरे यार राइट का साइज राइट का साइज जो है लेफ्ट का साइज जो है अगर उससे बड़ा है. चलो इसका सोल्यूशन देखते हैं. बहुत टाइम लगेगा इसमें. सबमिट कर रखा है कहीं पे. मैंने ऐड नंबर क्या लिखा है. एम्प्टी है मैक्स. ओके मैक्स का टॉप जो है बड़ा है उससे, तो उसमें कुछ करो. उसमें कुछ करो. उसके बैलेंस का क्या करता है. ठीक है ठीक है. बैलेंस का कोड लिखा है सही है. इसको अगर मैं ऐसे भी कर देता हूँ तो भी चलना चाहिए. फाइंड मीडियम का ठीक है. दैट्स करेक्ट. शाबाश मेरे बेटे. कहाँ पे दिक्कत था. दिक्कत था इसमें कि लेफ्ट के टॉप को चेक करना है कि अगर उससे बड़ा है जो एलिमेंट